Welcome back, Algebra students. In this lesson, we're going to continue talking about the slope and a rate of change. And we're going to find the slopes of several different types of either graphs or tables. Sometimes we're going to do it for just points. But before we do that, let's talk about slopes of special kinds of lines. We're going to talk about the slope of a horizontal or a vertical line. Okay, so when we have a horizontal line, we're going to have a special kind of graph that shows that the slope is 0. For a horizontal graph, the slope is 0. Because what is the rise of a horizontal graph? There is no rise. It's 0. It goes up 0 units for each unit it goes over. If the slope is 0, we're going to get an equation that looks like this for a horizontal line. Y equals whatever the constant number is. Because this graph, it doesn't matter what the x is, it's constantly at the same value. In this case, this horizontal line is constantly at 2. If we have a vertical line, the rise is really infinite because there is no, how far does this go up? It just keeps going up and up and up forever. And the run is 0. Now, if I divide anything by 0, it's undefined. So we say the slope of a vertical line is undefined. You have to just remember, a horizontal line has a slope of 0. A vertical line has an undefined slope. Vertical lines are of the form x equals our constant. So this line would be at x equals 3. Now, I just want to point something out. There's something that's a little counterintuitive here that tends to make students in algebra confused. See, oftentimes we think of vertical lines as being associated with the y-axis because y is our vertical axis. So shouldn't it be y equals 3? Well, it just doesn't work out that way. The reason why the graph is x equals 3 of this line is because it doesn't matter what y is, x is always going to be equal to 3. You have to remember that for vertical lines, the equation is going to refer to what the x value is, and then vertically it can take on any value because the y can be any value. And the opposite is true for horizontal lines. Instead of the x value, we're talking about the y value. For a horizontal line, we state that the y value equals something, and it's always equal to that thing regardless of what the x value is. By defining a y value, it frees up the x value to take on any value. And the same is true in the vertical. All right, let's do some practice problems. Letter A asks us to use the graph to find the rate of change. Well, this shouldn't be too hard because we just need to find a rise and a run between 2 points. We could use any 2 points, but I'm going to use 2 consecutive points because that's the easiest. So as I look at this, we go up. Now I have to look at my scales. It looks like we go up 2, but actually this is going up. This graph counts up by 2. So we go 2, 4. My rise, let's see, I'm just going to write slope equals rise over run equals 4 for a rise. And my run is going to be 1, 2. And since my horizontal axis counts up, oh, hold on one second. Does it count up by ones? Actually, it counts up by halves. So as I go over, it's 1/2 1, right? From 1 to 2 is just 1 unit. So my slope is 4 over 1 or just 4 for this first one. Let's take a look at B. In B, I'm going to have to do some math. I need to figure out what 26,400 minus 15,840 is. I wonder. The reason I'm doing this is because I think that each of these is going to be the same distance apart. If I could figure out what the distance they are apart is, that would help me figure out my run. So I've got miles and feet. Let me think about that for a second. Actually, feet is going to be the rise and miles is going to be the run. Usually when I make a table like this, my top row is my x-axis, and my bottom row is my y-axis. All right, let's do 26,400 minus 15,840. Got 0 minus 0. 0 minus 4, I'm going to have to borrow from the 4. So I'm going to make that a 6. Okay. Here, let me just line everything up. This I borrowed from, so this becomes a 3. I'm going to need to borrow again from this. So this becomes 13 minus 8 is 5. Okay, and then let's see, this I borrowed from, so 5 minus 5 is 0, 2 minus 1 is 1. This becomes 10,560 feet. Now I just want to take a look. Is this going to go up by 10,560 every time? 26,400 plus 10,560? Well, that's going to be 36,960. Yes. And then this one would be, if I added 10,560 to this number, it'd be 47,520. Yes. Okay, so this goes up by 10,560 each time. So that means that for every 2 that I go over, remember, my slope equals rise over run. My rise is actually going to be my feet value. So it's going to be 10,560. And then my run is going to be how far over in the x I go. For every mile, every 2 miles I go up by 10,560 feet. I'm going up by 2 miles each time in the chart, so it's going to be over 2. So that means that my actual slope is going to be, let's see, what's 10,560 over 2? 5,000, I want to say 280. Oh, look at that. So there's 5,280. Hey, what is my rise measured in? My rise is measured in feet, and then my run is measured in miles. So it's going to be 5,280 feet per mile. Does that ring true? Should. All right, letter C. Find the slope of the line. Ooh, now I don't have any points pictured, so what I need to do is look in the background and find places where this line perfectly crosses intersections on the grid. I see there's one crossing here at 1, 5. There's another crossing here at 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. 1, 5 to 2, 8. Hey, how far over does that go between crossings? 1. My run is just 1. Okay, so I'm just going to say slope equals rise over run equals, I know my run is 1. What is the rise for every 1 it goes over? Well, let's look at the rise from here to here. 1, 2, 3. My slope is going to be 3 over 1, which is actually just equal to 3. And that's all it takes. Let's look at letter D. Oh, this one's going downward. Notice it's sloping downward from left to right. All right, let's find places where it perfectly crosses grid work in the background. I notice it perfectly crosses at 0, -1. So we're going to start right here. And then it doesn't look like it perfectly crosses anywhere else until it gets all the way to the end at, let's see, this is 2, 4, 6, 8, 10, 10, -6, because this counts up by 2's. 10, -6. So we go from 0, -2 to 10, -6. Let's see. Again, my slope is going to be my rise over run. Hey, what's the rise in this case? It goes down 2, down 4. That's going to be -4 over, and then my run goes over 2, 4, 6, 8, 10. -4 over 10 is the same as -2 over 5. All right, letter E. We need to find the slope of the horizontal line that passes through the points 5, 3, and 8, 3. Whoa, wait a second, though. This one very specifically says it's a horizontal line. Horizontal lines always have a slope of 0. Okay, so I don't have to do any calculation. I could calculate that the rise is 0 if I wanted to there, but it says horizontal, so I don't have to worry about it. And then for letter F, it's the slope of a vertical line. The slope is undefined because it's a vertical line. I just know that that's true without even doing any calculations. Let's go up to G. Use the table or graph to find the slope of the line. How can we do this? Well, again, this is my X on top. This is my Y on the bottom. Y is going to give me my rise, and X is going to give me my run. And I see that, okay, so the table shows the number of times Ileana kicked her bass drum during each measure in a song. So let's see. It looks like she's kicking at how many times per measure? Well, it goes up by 4 over 1. Up by 4 over 1. So let's see. That means for my slope, it's going to equal rise over run. Up 4 over 1. That means it's 4. And I can give this one a label because I see I have a y-axis and an x-axis. It's going to be drum kicks per measure. Drum kicks per measure. All right, and then lastly, letter H. In letter H, what does the rate of change mean in this problem? Well, it's actually in the label, right? Once we look at the label, we should be able to figure that out. It's the number of drum kicks per measure. And I just get that from dividing whatever's on the y-axis by whatever's on the x-axis. All right, that is how you do slope problems. This is not that hard. What's hard to do is to remember that you have to use rise over run to find this. It's something that's easy to forget as we do this again and again this year. Don't forget it. Practice, 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 and make sure you keep that in mind. All right, you are ready to do numbers 1 through 30 for next time.